Now, can I have everybody's undivided attention for next 50 minutes?
50.
Yeah, 50 minutes. 55, 52 minutes maybe. Alright. So, take a deep breath. So, for all the kids who have joined recently, this is for you guys to be aware of the fact that whatever we do in the class, that gets recorded, and I upload the video of the class on YouTube so that you guys can refer to it. Okay? And it is only for you guys. I'm not trying to get more views and all that. If it comes, it comes. I don't care. Yeah? But fact of the matter is, this video is only for you guys. So what I'm trying to say is, don't have to spend a lot of energy and time noting down while I'm teaching. Okay? So you guys can focus more on following the concepts, and if there's something that you're not able to follow, feel free to ask questions. Make sure that those are thought through questions. You are doing your thinking before asking the question, because no, otherwise everybody's time is equally important. So that's what we'll be mindful of. So right now, in today's class, we are going to talk about ratios and proportions. That's what we discussed. We have talked about linear equations, coordinate planes, slope of linear equations, whatnot, slope-intercept form. And then today we are going to talk about ratios and proportions. And this class is level 2, where we learn all the concepts from 6th grade till 8th grade. So there are kids from 6th grade, there are kids from 8th grade also. We'll cover all the concepts for these 3 grades in next 1 to 1.5 years. That is what the goal is. Yep. Amoga, you're saying something?
No.
Okay, I saw your hand. I felt like, okay, you're asking a question. Okay, all right. So that is the premise of what we're going to start with. So anybody having any question, any concept that is not clear to you, always feel free to let me know few days in advance, so that before the class I can teach those concepts. Otherwise, I'll go with my flow, and that is in this book, which has all the concepts, all the topics that we need to learn from 6th to 8th grade. And some of you would go from here to level 3, which is for SAT preparation. So I already have few names in my mind, but that will be only for people who are sensible enough and have picked up concepts. All right. So let's get going. Do you want to go to college? So Arif, don't touch my threshold. You are very close to that threshold now. All right. Now let's focus on learning something. We are going to talk about ratios and proportions. Now, I want to understand what is that you interpret or relate to when it comes to ratio. Anybody who can explain me in simpler terms, who has not been banned for talking for next 2 days? Yeah, Dikshita, tell me. What is your understanding of ratio?
I think that they're two paired terms.
Ratio, only ratio. If I say, explain me what is a ratio in layman's term, assuming, yeah.
A fraction?
Ratio is a fraction. Okay, that's one example. Okay. Let's see what Aryan has to say. Yeah.
So a ratio is like two numbers that like for example, like a meat to bread ratio, like more meat, less bread, like that type of ratio.
Okay, two numbers being compared with each other. Yeah, Amoga, you have another way to explain it?
It's like a relationship,
Relationship.
between stuff,
Yeah. Yeah.
numbers or something like.
Okay. I think I got enough definitions. I'll probably hold it there. So ratio is very simple. It's when you look at ratio, you essentially have two numbers in mind. If I say this is not a ratio.
That's a number.
If I say this is not a ratio. But if I have this, it's a ratio. When 6 is compared against 8 or 8 is compared against 6. When there are two numbers compared with each other, that is when you are talking about ratio. So 200, 400 कुछ नहीं चलेगा आज. You have to
I actually have a real good question.
No, you are not being allowed, Madhav. I'm trying to teach you something. which is called discipline.
Discipline.
This is outside the syllabus, but I have to teach you. Otherwise, you will not let anybody learn anything in the class, including yourself.
That's an N.
I'm being very serious. I'm being very serious. Okay. The Bhupal, here. Everybody here. So take this as a learning of your life. If you don't listen, if you don't follow the basic protocol, you will be penalized. This is the smallest of the penalty that you can come across. I talked to your daddy, I'll not. This is only a deal between you and me right now. I'll let it be like this, unless you want this to be aggravated. Okay? Hold it there. Promise yourself. I will make sure that you learn anything that I'm teaching here. I will keep on repeating myself. But then I'll not let you speak. And one more time, not acceptable. So today and Saturday. Remember this. Okay? Alright. So everybody here. Now, so when we say ratio, we are talking about two numbers being compared with each other. Yeah, Muga.
They can be written in different ways, right?
They can be different in different ways. So I'm starting with a simpler form, and we can go on to different forms. Yeah.
Is there a symbol for ratio? Yeah,
You can write it like this also.
Yeah.
So I'm going step by step. Okay. So you'll have to have some patience. I will put the concept deep into your brains first, and then I'll put the sugar coating, coloring, beautification, user interface around it. Okay. All right. So simple terms, when you say ratio, you're talking about two numbers being compared with each other. Now look at this number and look at this number. What do you see here? Yeah, Vishal, welcome to you.
They both are like alike.
They are alike?
If you multiply it by 2, both like 2 by 2, it will be 6 by 8.
They are the same number value actually. Yeah, Vivan.
They're like like terms.
Yep, Vivan. Is that the same answer for you? They are the same number actually. Yeah. Now, let me give you guys one more example.
They're
Yeah, Moga, go ahead.
they're equivalent.
They are equivalent. Now, let me give you one more example. If any of you are interested in baking, you want to make cake or pastries or muffins, okay? This is your cake. This is a smaller cake. Smallest cake ever. When you are making cake or when you are baking, what do you use? You use flour, sugar, egg, baking powder, whatever. Yeah. Let's say you add 2 cups of flour, 1 cup of sugar, and 2 eggs for this bigger cake. Would you ever, don't keep murmuring in between, okay? When you want to make a bigger cake, 2 times the size of this cake, here you are adding 2 cups of flour, 1 cup of sugar, and let's say 2 eggs. If you have to make a cake which is 2 times the size of this cake, you would need 4 cups of flour. Instead of 1 cup of sugar, you will need 2 cups of sugar. And you would need probably 4 eggs. Yeah. What is that I'm trying to show here?
So like if you increase it by 2, all the other numbers increase by 2 since it's like 2 times bigger.
Mm-hmm. But I have a hidden agenda. Yes.
The size of the cake increases.
The
Or
size
like
of
the
the
taste because you're putting more ingredients.
No, I'm not trying to change the taste. I'm saying that I'm just trying to make it bigger.
Yeah.
The flavor remains the same. I'm not going to spoil it or make it better. But yeah, Dikshita, and V1.
Then like if we add 2 more, we'll get like another recipe.
No, see again, let me repeat the question. If I'm making this size of cake, I need 2 cups of flour, 1 cup of sugar and 2 eggs. If I want to make a cake 2 times the size of this one, I will probably need 4 cups of flour, 2 cups of sugar and 4 eggs. What is that I'm trying to show here? What is that I'm trying to... No, let us also speak. Yeah, Amuga.
You added a different ratio of
No, I did not change the ratio. See?
you like
Ratio is the same. I mean, the flour to sugar ratio here, it was 2 by 1, it is 4 by 2. It is eventually 2 by 1 again. Yeah? Yeah? V1, you are saying something.
Sir, so is ratio like an agreement between two numbers?
It's a, I would not say agreement, it's the relationship. Meaning 6 to 8. How is 6 doing against 8? And how is 8 doing against 6? That is what would be my interpretation of ratio. But yeah, I'm asking a different question right now. I'm saying I'm making a cake with this combination. I want to make the cake 2 times the size of this cake. So I increase the ingredients by 2 units. What is this situation? I mean, anything that you guys can relate. Gitesh, you're saying something. Go ahead.
You're like multiplying everything by 2 and like
Yeah, no, that I did. That is visible, right? 2 cups of flour became 4 cups of flour. 1 cup of sugar became 2 cups of sugar. 2 eggs became 4 eggs. So that is understood. But I'm trying to hear a magical word. Yeah, Vishal.
I think you're trying to like show how the relationship between that and this are equal, like they taste the same or something like that.
You are getting closer to it, but you have not spoken the magical word yet. Yeah, Gitesh, one last attempt.
the ratio of baking a cake is 4 to 2 and 2.
You are getting close, but I'll not give you third chance. Yeah, you had raised hand. No? Okay. Okay. Alright. So the answer is proportion. This is called proportion. Okay? So see here, flour to sugar ratio. 2 cups of flour, 1 cup of sugar. 2:1. Here 4 cups of flour, 2 cups of sugar. 4:2, which is same as 2:1. So here we say this is used in the same proportion. Unless you want to be a cook like me and spoil the cake. You'll use the same proportion, same ratio. Let's say if you are making a curry, 16 ounce of curry and you're using 14 ounce of vegetable and 2 ounce of, let's say, spices. If you have to make 32 ounce of curry, you will use, so let's say 16 ounce, you are using 14 ounce of vegetables and 2 ounce of spices. If you have to make 32 ounce,
28.
so you will make 28
4.
and 4. This is what is called proportion. When you mix the ingredients with a certain relationship. 2 ingredients are having a common relationship among them, regardless of the size or the quantity that you are trying to prepare. That's called proportion. So this is ratio and this is scenario of proportion. Now let's look at, did you guys get what I'm trying to say?
Yeah.
Everybody? You stay outside the classroom. You stay outside the classroom. What did you do just now? Tell me.
I didn't understand like the 16 by 14.
You'll have to watch the video 2 times after the class. You don't have a choice today. Yeah. If I commit a mistake, if I don't do my work, I'll not get my salary, right? So I'll have to wait for next salary. Same thing for you. You made a mistake where I kept on stopping you and you did not listen to me. Now when I'm saying, did you understand it? And this attitude I don't like. Please don't force me to talk to parents. You have to watch the video. You have to acknowledge this is a mistake, and I will force that you understand that. Okay? Yeah.
So if it's 64, then the proportion.
So see, look at this. This is a proportion. Flour to sugar ratio is 2:1. 2:1. If you want to make it 10 times bigger, multiply this by 10, multiply this by 10. Simple.
Could it be in decimals?
That question is of no value. Because if I am making this smaller, that is what will happen. Yeah. So see, 2:1 is what I am saying. Now 0.5 is to 0.25 is also the same way. So that question is not holding much water actually. Yeah. Yeah. So ratio and proportion. I'm getting a little distracted, guys, because I have to be mindful of everybody's effective use of time, right? So that's what teachers and parents end up doing at times. But yeah, bear with me. Alright, so did you guys understand the basic concept behind ratio and proportion? When I say ratio, it's very simple. Two numbers compared with each other. One number against the second number. When I say proportion, it's a scenario where you will deal with it. Let's say you would have seen people constructing houses where they mix cement and the sand. That is mixed in a certain ratio, certain proportion. 2 packets of sand and 1 packet of cement. They have to use the same proportion, meaning if you are using 10 packets of sand, then they need 5 packets of cement. If they are using 40 packets of sand, they need 20 packets of cement. That's the proportion. They have to use that proportion. Otherwise, the house will become weaker or stronger. If they are using 2 packets of cement, 2 packets of sand, probably that will make the house much more stronger than what it's supposed to be. And then there might be some side effects also. So the proportion is always used in a situation like where you have to deal with different mixtures and one ingredient to another ingredient's relationship or the ratio or the comparison of the two ingredients. Balance or ratio again, ratio among those ingredients. So here flour to sugar ratio will be 2:1. You can call that a proportion also. So ratio and proportions are used very interchangeably, but ratio in absolute terms is nothing but comparing two numbers against each other. Is that part clear?
Yeah.
Everybody?
Yes, sir.
Okay. Now let's look at a real life example. So I'm giving a small breather to one of my students here in the classroom. I'm giving you a relaxation today. Okay, I will let you speak. Okay, but only genuine discussions, only genuine questions. No mistakes or no repeat of a mistake. Okay, yeah, is that okay? Yeah, all right. So here, now let's say I'm making let's say for a chemical reaction. Okay. Now you'll have to wait till I complete my sentence. Yeah. For a chemical reaction, okay, sodium to chlorine has to be mixed in 5:1 ratio, and we need to keep, let me not write so much of English, ratio, how much of chlorine we would need for 20 milliliter of sodium for the same reaction. Who can solve this? Let me read this question for you guys. Let me read this question for you guys. So like I always say,
R.
Nike comes towards the end when you just do it. Read, analyze, and then you do it. So don't rush for doing it. Just raise in the hand. Put it down. Think. Let me repeat the question. For a chemical reaction, sodium and chlorine has to be mixed in a ratio 5:1. How much of chlorine we would need for 20 milliliter of sodium if we have to keep the same proportion? Do it. Use pen and paper. Yeah, Vishal.
Can you repeat the question again?
Yes, I like that. Read the question again and again. For a chemical reaction between sodium and chlorine, it has to be mixed in a ratio 5:1. For a chemical reaction, sodium and chlorine has to be mixed in a ratio 5:1.
Which one is chlorine and which one is?
Sodium to chlorine, I said. Sodium and chlorine 5:1. Okay? 5:1. How much of chlorine we would need for 20 milliliter of sodium? I see many of you have raised hand to solve it or to ask the question again. Okay?
Sir,
Yeah?
can you repeat the last part again?
Yeah. So let me repeat from the beginning itself. For a chemical reaction between sodium and chlorine has to be mixed in a ratio 5:1. How much of chlorine we would need for 20 ml of sodium? Okay.
We have sodium.
20 milliliter of sodium. How much of chlorine we would need for 20 milliliter of sodium? For sodium and chlorine, the ratio has to be 5:1.
Is it 40?
No thinking. Do it and show me. Yep, Amoga, how much it is?
Is this 4?
Same. Same.
Okay.
Because
I, 4. When I have to ask, I will ask. 4, okay. Same thing for you? 4? Okay. Vishal, how much it is for you?
I got 4 too.
4 too, okay.
I got 4.
Dikshita,
I got 4 too, sir.
okay.
I got 4 too, sir.
Everybody got 4. There's nothing for me to do then. Okay. Aryan,
can you turn on the fan?
The ratio of chlorine would be 4.
4 what?
20 to 4.
4 milliliters.
Yeah, 4 milliliters.
Okay. How about you, Pranav?
I got 4 milliliters too.
Okay. All right. So, all right. Yep. So everybody got the answer. When it comes to ratio and proportions, these are real life problems that you deal with every day. I don't know how many of you make tea. I do it every day morning,
Same.
right? So when you make tea, you know that okay, you have to mix water and milk in a certain ratio, and then you know if I'm making 1 cup of tea, I would need 1 spoon of tea leaf or whatever, right? Similarly, if I'm making 4 cups of tea, I will need 3 cups of milk, 1 cup of 3 cups of water, 1 cup of milk. So it's a ratio that you deal with every day. There is not much of a complication that you have to deal with, but how you will solve it is going to be plain simple English. If you use English for solving this kind of problem, it becomes very easy. This is the most basic part of the algebra that we deal with every day. Let's say I say here the question was, everybody has solved it right, so there's nothing to teach, but I'm just telling you how will I do it as a student. I got a ratio saying between sodium and chlorine, 5:1. This is my ratio. The question was how much of chlorine I would need, for 20 ml of sodium. See, this is simple English. I need to find out how much of chlorine. Okay, so chlorine will be on my right hand side. What is that I know will be on my left hand side. So I know this relationship. It says 5:1, meaning for 5 milliliter of sodium, I would need 1 milliliter of chlorine. So if I have to take 1 milliliter of chlorine, for 1 milliliter of sodium, how much of chlorine I would need? 1, whatever is for 5, divide by that number. 1 by 5 milliliter of.
0.2.
No, don't rush. No hurry. Nike keeps stopping you. Nike is calling you. Okay? Now, for one, see, always go with this approach. You find out the value for 1 unit. If you find the value for 1 unit, if you have to find for 50, multiply by 50. If you have to find for 100, you'll multiply by 100. So here, we have to find it for 20 ml. So what did we do? 5 ml would need 1 milliliter of chlorine. So 1 milliliter will need how much? This much. Okay, wonderful. We'll keep it there. Now, if I had to find out for 10, I would have multiplied by 10. If I had to find out for 100, I would have multiplied by 100. If I had to find out for 5,000, I would have multiplied by 5,000. I had to find for 20 ml. So what if my amount of sodium is 20 ml? It will be 1 by 5. Whatever was the value for 1 unit, multiply that by 20. This many milliliter of chlorine. And that is where the answer is. So write this like a English, okay? Whatever you see in the question, write this like a, and always make sure that whatever you have to find, you write on the left hand side. Right hand side. So you'll say, okay, whatever I have to find, I have to put it on this side. So I have to find for chlorine. Had it been sodium, I would have put the value for sodium here. So let's say if the question was, how many milliliter of sodium you would need for 20 milliliter of chlorine. So now here, see, for 5 milliliter of sodium, you would need 1 milliliter of chlorine. What you know is this one. If you have to find it out for this much of chlorine, how much of sodium you would need, you will change this whole thing. Five milliliter of, see, you will say, okay, now for 1 milliliter of chlorine, I need 5 milliliter of sodium. So if I have to find it out for 20 milliliter of chlorine, how much of sodium I would need? 1 milliliter chlorine case, you already found that you would need this much of. So for 20, you will multiply this by 20. As simple as that. So always try to find it for 1 unit. Once you find the value for 1 unit, you can multiply that by whatever you have to find the answer for. So in this topic, I am still struggling with myself. What is that I am teaching you guys? There is nothing to teach. This is something that you guys already know. It's just about how do you put that in the form of an equation, how do you put your interpretation on a piece of paper when you're trying to solve it, and then how do you go about it. So if you put in the right manner, your answer would not go wrong. Okay, that should be your approach. Look at it like an English and then you use it. So this is where I'm just stopping for ratio and proportion. I'm kind of tempted to pick up another topic because ratio and proportion I cannot talk for 1 hour. That will be a waste of time. So I would rather want to move on to another topic rather than wasting your 30 more minutes talking about ratio and proportion. Yeah. Or if you have any questions on ratio and proportion, you can always ask me. But then I'm just stopping it here. Any questions on ratio and proportion? I will rather give you guys some problems to solve, and that would let us know if there is something that we actually want to spend time on. Otherwise, we'll move on with other topic. So let me pick up another topic that we want to learn today.
Pick a random one.
I'm picking a random one.
A random imaginary one.
Okay. Who all in this group is very comfortable with exponents? Everybody is comfortable with exponents?
Yeah.
Everybody?
Did you talk to did you?
No. I'll just answer the question. Are you very comfortable with exponents?
Yeah.
Okay.
Yeah.
Everybody?
LOL.
Yeah.
Okay.
Yes, sir.
Let's see.
He taught us this.
So, just because we have 20 more minutes, let's use these 20 minutes to assess our comfort with exponents, and then we will go to the next topic. Okay?
Isn't the next topic algebra?
Is that okay? Amoga, you're saying something? No?
No.
Okay. Let's see. And I'm not intending to prove you guys wrong. If I give you guys something tough to answer, that means there's an opportunity to learn. That's how I look at it. Okay? 4 to the power 1 by 3 to the power 2. Can somebody tell me what is the answer for this one? Can you guys solve it? Solve it. Math is all about doing it. 4 to the power 1 by 3 in bracket to the power 2.
You have a pencil?
How much is this?
It's 8 by 3.
Huh?
8 by 3.
Now I saw the expertise.
It was 16 by 3. This is my first time I got it.
So my question was simple. Who all thinks they are expert in exponents? And the first person who raised the hand saying I'm an expert, I got my interpretation already. Let's see. So, calm down. If you really want to learn, you have to be very humble and down to earth.
I love math. English.
Loving math is not about hugging math, it's about doing math. Okay?
I don't know, marrying man.
Huh. Okay, I want everybody to solve this problem instead of wasting time on talking. You got 16 by what? 16 by 3?
Yeah.
How do you write it? 16 by 3, this is the answer?
Yeah.
Very nice. Another disappointment or reason to be happy?
That's me.
I know, it is. That's mean. See, I ask simple question. Okay, let's see, Amoga, what is the answer?
Wait, is it like 4 by 9?
4 by 9? Nope.
It's not.
Nope. I'll explain. See, so
I got
that's
16 over 3.
16 over
3. I got the same thing.
16 over 3? No.
Yeah.
Wow. That's
No. No. So I think we are missing some of the basic concept. I'll give 2 more minutes to see if I get another answer. Otherwise, I will probably do a quick recap of what you guys need to recollect before you do it. And stop dancing. This is not a dance class. Yeah, Dikshita.
I got 8.66.
8.66. How do you do it? I hope it's not the calculator who's helping you.
oh wait.
No,
What?
sir.
Okay, let's see. I'll come to that. Okay, Aryan, you are raising hand.
I'm not too.
Okay, everybody calm down. Everybody calm down. Thanu, you got some answer? Okay, yeah.
26 over 3.
26 over 3.
26 over 3.
Okay. Okay.
Does it have to be in like fraction form?
I mean, I would not assume anything. I would just go with the basic things that we know about exponents.
Okay. Wait, is it the... Never mind.
Okay. All right. So, Dikshita, you have to say something, or I can start with my magic.
Your math.
Okay. All right. Yeah. Yeah, Vasu, you have to say something.
I got 16 over 9.
16 over 9. So I think we are missing something here, okay? So let's we have just 17 more minutes. Can we have everybody's attention here? Advik, not fun. That's not funny. Close it down. Pay attention here. Okay, everybody here. So the question was this. 4 to the power 1 by 3 to the power 2. Yeah, Aryan. Okay.
I think like 18.7. I don't.
Leave it. No, so let's do a quick. So Vishal, I will probably not let anybody answer it now because everybody is making interesting guesses, and that will not be.
Is it 0.4?
So
I got 16 over 3.
I'm loving all the guesses, but none of them are convincing enough. So let's stop it there. Let's stop it there. Now let's go back to some of the basics because basics are the backbone of what we learn. So I'm not letting anybody give any guesses now. Let's come back to the basic concept that we know about exponents, and then we'll try getting with that here. Bhupal here, out of here. 10 more seconds to recollect yourself, and then we'll start. Okay? Yeah. So what do we know? We know x to the power a multiplied by x to the power b in exponents is equal to x to the power a plus b. This one you guys have seen enough?
Yep. A, B.
Seen enough? Yes or no? Mein? Ho gaya. Okay. Now, the next thing is, now this one also you have seen. 3 to power 2 into 3 to power 1 will be 3 to power 2 plus 1. And you know it. 3 to power 2 is 3 into 3. This is as good as 3 to power 3. So this formula that you have already seen, I just did it for the sake of simplicity so that it helps you recollect. Now, x to the power a divided by x to the power b is what? X to the power minus b. A minus b. Everybody remembers this, correct?
Yep.
Now, there is a third formula that we had learned. That is called x to the power a to the power b is nothing but x to the power a into b. Yeah? Everybody recalls this, right?
Yes.
Yeah? Now go back to what was the question? 4 to the power 1 by 3 to the power 2. How is this different from this equation or this rule?
I got the answer.
Wait. Nobody got any respectable answer. Okay? Nobody got any respectful answer. So don't brag about it. Now, this is the formula. X to the power a to the power b is equal to x to the power a into b. This is x, this is a, this is b. That means 4 to the power 1 by 3 into 2. That is nothing but 4 to the power 2 by 3. Okay? That means what?
Division.
Besides that, so it means that.
Nobody thinks anything. Now it's my turn. You guys have given me a chance to talk. Now, anything to the power 2 by 3 or 1 by 3 or 1 by 2. Do you remember? If I have 2 squared, this is simple. 2 to the power 1 by 2 is nothing but square root of 2.
Oh.
2 to the power 1 by 3 is nothing but cube root of 2. So what you see here, you can as well write this as 4 to the power 2 to the power 1 by 3. Same thing. 2 into 1 by 3 or 1 by 3 into 2, the same thing. So this becomes 4 to the power 2 is 16 to the power 1 by 3, which is nothing but cube root of 16. So this means this equals cube root of 16. This is what the answer would have been. Now whether square root of 16 is 2.4, 3.9, 4.6, that calculator will tell. I cannot. Okay?
Wait,
Are you guys able to relate?
yeah, it's too easy.
Don't say it's too easy.
All the ease, all the comfort was visible few minutes ago. Okay?
Imagine it was
So don't brag about things that you don't know. Okay? Everybody said, I am champion in exponent. You are not. What it means is, I'm not. Advik, will you get extra brownie points for that? No, don't do that. Don't do that. I don't like indiscipline. Okay? Alright. Yeah, Vishal.
I also got cube root 16 because x to the power of a divided by b is also equal to b square root x
Yes.
and a power.
Right. No, so that's what I was waiting for. I got answers, but none of the answers were convincing enough. And it gave me an opportunity to explain that, right? So, okay, everybody here. Everybody here. So on similar lines, see, these are not very complicated things. Okay. So, calm down. Everybody calm down. Everybody. Take a deep breath, settle down. Class is not for making fun of yourself. Yeah? And the last thing that you would want me to do is talk to somebody. Yeah? Okay. Alright, so now, what you guys would need to remember is this. If I have 4 to the power 3, this is very simple. This is 4 cube, which is nothing but 4 into 4 into 4. If I have, RF, you'll have to stay outside the class for next 10 minutes.
No, because see, Advik is.
No, Advik, I'm not worried about Advik.
I'm not laughing.
If you cannot, see, this is what happens. You get caught for your mistakes. Either you be smart or you don't make mistakes. One of the two options. Okay? If you make mistake and you're not going to handle it, then the problem. When I have 4 to the power 3, that is this. 4 into 4 into 4. If I have anything as a fraction, this is called rational exponents. This is nothing but, this is square root of 4. If I say 6 to the power 1 by 4, this means 4th root of 6. That is how you have to relate it.
Is that 6 to the power of 4?
Listen, don't talk. You're not teaching. I'm teaching for the God's sake. Yeah? I said 4 to the power 1 by 2 is what? Square root of 4. 1 by 2 is square root. If I say something to the power 1 by 3, that is nothing but cube root. This is another form of exponent which is called rational exponent. Meaning where the exponent is in the form of a rational number or fraction, which can relate with the roots. Okay? So if, let's say, if I ask you guys to solve this problem, if I say find out 64 to the power 1 by 6 multiplied by 2 by 3 equals what?
So it'll be 64 to the power of 6 by, sorry, it'll be 160 to the power.
Math is done on a book, notebook. Do it there. So 64 to the power 1 by 6 to the power 2 by 3 will be as simple as, I will relate this with our formula that fine. 64 to the power 1 by 6. So this is x to the power a to the power b. Yeah, Vishal. I am doing it for the sake of the class, and everybody who has done it, just look at if I am doing it the same way.
yes. I got it.
Yes? So this is nothing but 64 to the power 1 into 2,
2 by 6, 8.
So it'll be 163
1 by 9.
It'll be 2 by 6, 18.
You can simplify.
Yeah. So
Yeah,
this equals nothing but 64 ninth root of 64. That's what it is. Yeah?
Can I see the number?
not regular. I don't know how to react in such a situation. I don't really know how to react. Yeah. Okay. All right. So here with exponents, when you talk about, there are three key rules that you have to be aware of. One is x to the power a into x to the power b equals x to the power a plus b. X to the power a divided by x to the power b is equals x to the power a minus b. X to the power a to the power b is nothing but x to the power a into b. These are the basic thumb rules. And then apart from this, if you extend this understanding beyond regular exponents, there is something called rational exponents, where your power to the number is not a natural number; it's an exponent. It's a rational number or a fraction. So that is where you end up dealing with x to the power 1 by 2 into x to the power 1 by 4, let's say. If you deal with this, your power is not natural number, they are rational numbers. So but the approach remains the same. So here it will become x to the power 1 by 2 plus 1 by 4, and then you will add it up and then you deal with it. So basically exponent remains the same, just that you end up dealing with one more flavor of it. I have not given you a luxury of asking questions. I had just given you a chance. Just hold it down. Put it down. And whatever you are doing, I'm not liking it right now. Just laughing at everything when you are already being punished. And I gave you a relaxation today. Everybody is listening to it, and it's getting recorded also, unfortunately. So this is one extra flavor of exponents that you would deal with. And I was not intending to make you guys feel that you don't know exponents. I was just wanting to make sure that you understand one more flavor of exponent, which is not different from what we already know. This is an additional flavor to it. Okay? Yeah, Dikshita, your question.
In the x place, what if we don't have like a x and instead of x we have 1, like something like number?
Doesn't matter. Same thing. Calculation remains the same. X is a variable. And x's value could be 1, it could be 100, it could be 0.5, it could be 0.25, it could be minus 8 also. Doesn't matter. Yeah?
Okay, sir.
So what if an exponent is negative?
Same thing. Or exponent is negative. So that's something that we have learned in the previous class also. But let's see if anybody doesn't remember it. If x to the power minus 4, do you guys remember what exactly it is?
Oh,
X.
1 by.
I'll not give you a chance today. Laughing gives you extra brownie points. Not you also. Great. Yeah, Vishal.
X by 4? And
No.
like x over 4?
No. This is. No. You stop drawing. You stop laughing. You stop being more respectful and mindful of the time that we spend in the class. I'm not liking certain things. That's why I said I don't know how to react. You don't have a chance at all. You can't. I'll make sure Saturday you're not able to speak. Only your ears will work, not the lips. Okay? Alright. So yeah, x to the power minus 4. What was the answer? Anybody else? If I have a negative exponent, what does it mean? Yeah, Aryan.
Does it mean that it's not solvable?
No.
Will it be negative?
No.
Will it
Now,
be
now again go back to basics. Basics are the most important part of life. If I say x to the power a divided by x to the power b, what does it mean? X to the power a minus b. Correct?
Yeah. Correct.
You will not even say correct. So here, yes, Sanvi, sorry.
It's 1 over x to the power of y.
Yes, that is what it is coming down to, and I am saying that in a very simple way. Now, since we know this formula, I can say x power minus 4 is nothing but 0 minus 4. Is that fair?
Yeah.
If I do so, that means x to the power 0 divided by x power 4. Yeah?
Yeah, because see,
X, yeah? Anything to the power 0 is what?
1.
What happened, Vishal? This guy moved down. Yep.
Yeah, I forgot about the exponent.
No, so that's fine. See, I will just help you to relate these things. If anybody says x power minus 2, you will not even think about it. You will just make this guy move below, move down.
Opposites.
Yeah? If somebody says 1 by x power minus 2, what will you do? You will just move this becomes positive x to the power 2. Now you will ask me why. Same thing. Same thing. 1 by x power minus 2 I can write as 0 minus 2. That means 1 by x to the power 0 divided by x to the power 2. This guy flips and goes up. This becomes x to the power 2 divided by x to the power 0. X to the power 0 is nothing but 1. So this becomes 2. So here what happens is when you move the number with the exponents from numerator to denominator, the sign changes or vice versa. Okay?
So yours?
Is that one line interpretation good enough?
Yes.
Yes, sir.
Okay? So I hope whatever we did with the exponents, that is making some sense to you guys. Except few kids here who are busy laughing.
I get it. You guys thought
Yeah.
it's not funny.
Yeah? Alright. Everybody quiet. This is unfortunately it's recorded on YouTube. It'll go for public's consumption and you will hear your name so many times on YouTube in a public domain, interestingly.